Hey everybody, today we're going to talk about counting outcomes. We're going to do two different methods for doing this. The first one that we're going to do is called the tree diagram. Okay, this diagram is used to show the total number of possible outcomes in a probability experiment. The next one's called the fundamental counting principle. Leave me an in there. All right, the fundamental counting principle uses multiplication of numbers in each event and experiment and can occur to find the number of possible outcomes in a sample space. So first, let's look at the tree diagrams. A new polo shirt's released. It's got 4 different colors, 5 different sizes. How many different color and size combinations, how many different colors and size combinations do we have? Well, first, let's start with our colors. We'll go red, blue, green, yellow. Now, how many sizes do we have? We have 1, 2, 3, 4, 5. So your tree diagram will look like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now at the end of each branch, you'll have a size: small, medium, large, XL, and double XL. And that is the same for each one of these. Okay, how many different combinations do we have? Well, we can find out by counting on how many branches or how many sizes we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 different combinations. The fundamental counting principle, what we're going to use is the number of possible styles times the number of possible sizes. So if you notice, we have 4 possibilities or 4 possible colors with 5 different sizes. 4 times the 5 equals 20. So notice how both of these give you the same outcome. It's just different ways of looking at it. Sometimes a visual representation helps a little bit better than the multiplication. Tree diagrams and fundamental counting principles are 2 different ways to process or set of rules for finding sample space of a probability. And we'll call it methods, 2 different methods. So let's look at an example. Using the tree diagram, Tamara spins a spinner 2 times. What's her probability of spinning a green on the first spin and a blue on the second spin? The first thing we need to know is what kind of spinner are we looking at? This spinner only has blue and green on it. So let's say we have us a spinner, right? Half of it will be blue and half of it will be green. And then we have our little spinner. And you're going to flick it, just like playing a board game. Now, what's the probability of spinning a green on the first spin and spinning a blue on the second spin? Well, what do you have? You have a green and you have a blue, right? Those are your 2 choices. And then the second spin, you have a green and a blue. So that tells me if the first time the first time I spin the spinner, I'm going to get a green. Okay, so I have a 1 in 2 chance. And then on the second spin to get a blue. Well, how many leads down that same path? Only one. I can only get green on the first time because the other choice is blue. And then if I get that on the first time, my next choices are just green and blue. So I have 1 out of 4 chances, or 1/4 of a chance. Let's look at another possibility. If a lottery game is made up of 3 digits from 0 to 9, what's the probability of winning the game? Yeah? No guesses? Well, let me help you out. We're looking at 0 to 9. So how many numbers is that? If you guess 10, you'd be correct. Okay? Because 0 is a number. So you have 1 through 9 plus 0. That gives you 10. Now, it doesn't say that the digits can or cannot repeat. So we're going to assume that you can use the same number every time. That means you got 10 times 10 times 10. And what does that get you? What does 10 times 10 times 10 get you? That's going to give you 1,000. You have 1,000 possible outcomes. All right. So number 4. How many outfits are possible from a pair of jeans and khaki shorts and a choice of yellow, white, or blue shirt? Excuse me. How could we figure this out? Well, you could do it 2 different ways. You've got jean and khaki shorts and yellow, white, and blue. 1, 2, 3. Yellow, white, and blue. 1, 2, 3. Yellow, white, and blue. How many possible outcomes? 1, 2, 3, 4, 5, 6. Or you have jean and khaki shorts. That's 2 shorts times yellow, white, or blue shirt. 3 shirts equals 6. And if you notice, both principles will get you the same way. Okay? All right. That's the, let me see here, let's scroll down just to make sure. Okay, to keep the video a little short, we'll stop there. And you guys now take a look at your homework and let us know if you need any help.